In this example, we're asked to write each expression as a sum and or difference of logarithms, and we're asked to express powers as factors. So first we want to identify and look at all of these problems. All of these parts are asked, they're giving us an expression 1 log, 1 log, 1 log, 1 log. And we're asked to split it into a sum and or difference. So I want you to note that in this problem, we're going from 1 log to multiple logs. This is important because in other examples, you'll be asked to combine logarithms into one single. So you want to pay attention. Here you're starting with 1, and you're asked to split them up. Well, the property that allows us to split them up, if you remember, is if we're taking log of a quotient like this, we can split into a difference of logs. And here, if we're taking the log of a product, x times radical 1 plus x squared, then we can split this up into a sum. So those two properties allow us to do all of these. This is useful because when we solve equations in the next section, these properties will allow us to isolate x. So for now, look at this section as an exercise in some of these rules, which can be a little tricky when you first start. Get the rules down in this section, and then that will allow you to be more efficient in the next section when we solve equations. Okay, so part A, log base 3 of x over 9. So when we take log of a quotient, that property allows us to split this into log base 3 of x minus log base 3 of 9. So here we've split it up into a difference like the directions said, and then if we can evaluate any further, we want to do that. Well, this is just an x on here. We can't do log base 3 of x, but we can evaluate log base 3 of 9. So the power of 3 that would give us 9, or 3 to what power gives us 9, we can simplify that into a 2. So we have log base 3 of x minus 2. So like I said in previous sections, the logarithm stuff, a lot of these problems, they're not long. If you know the rules, these really shouldn't take you a long time. It just takes some practice learning the rules. All right, let's look at part B. We've got natural log of the product, x radical 1 plus x squared. And notice they're just noting here, x has to be greater than 0. And if you think why that could be, because we've got to keep the radicand here, we've got to keep the argument, the thing we're taking log of, it has to be greater than 0. So if we keep x greater than 0, it'll keep this product greater than 0. So that doesn't have anything to do with the simplifying this into a sum or difference. It's just a note there. Okay, so we've got this product, x times radical 1 plus x squared. So we can split this into the sum of natural log x and natural log radical 1 plus x squared. Now it's telling us here to express powers as factors. Well, as this is written, we don't see any necessarily powers of the argument, but if we look here, we've got 1 plus x squared under a square root, and we remember that a square root symbol is the 1/2 power. So if we rewrite this as natural log of the quantity 1 plus x squared to the 1/2 power, we want to take this power and express it as a factor, so we're going to move it out into the front. So we have that property that allows us to move the exponent out into the front and multiply. So we can split this into natural log of x plus 1/2 times natural log of 1 plus x squared. Now when you get to here, remember there's no rule that allows us to split log of a sum. So this is as far as this can be split up. Remember, the rule allows us to split log of a product or log of a quotient, but not a sum. So this is as far as this can be simplified. Okay, and then let's look at part C here together, and then I'd like you guys to try D on your own. So part C, so we've got log base 2 of the argument, x squared over cube root of x minus 3. And again, they're noting here that x has to be greater than 3, just so that we keep this argument positive. Okay, so we've got log of a quotient, so we can split this into log base 2 of x. I'll write this a little better here. Log base 2 of x cubed minus log base 2 of the cube root of x minus 3. So we've split it up into a difference, but now we've got to express these powers as factors. So here's a power, this cubed here on the argument x. So we can move that out into the front and multiply. And here we've got a cube root, which we can rewrite as 1/3 exponent. So we can write this as 3 times log base 2 of x minus log base 2 of x minus 3 to the 1/3 power. And then we can take this power, and as it asks us to express it as a factor, multiplication in the front. So this gives us 3 log base 2 of x minus 1/3 log base 2 of x minus 3. And I'd like you guys to try part D on your own, please.